This is Prashant Mohan Thakur from Competition Valley and Competition Valley, and we are again continuing the number system topic. We will be doing some good questions over here. I hope you would have been through the last video. This would give you a lot of time and a lot of concept to solve questions over here. So let's do over here. Let's start. How many factors of 2 to the power 8 into 3 to the power 6 into 5 to are multiple of, let's say, 90. Again, we have done such questions before as well. 90 is 15 into 6, so 3 into 5, or excuse me, into 1 into 3 into square into 5 into 1. So the total number of factors that we would have is 2 into 3 into 2, which would be 12. Okay, now what we need to say is we have been given 2 into 8 into 3 into 6 into 5 into 4. So what do we need to see? We need to see that how many factors of this would be multiple of 90. So this is what we have. So what we can take this is exactly the way we did how many would be even. So even number would be multiple of 2. So in 90 would be multiple of this part, whatever is given over here. So we can take this and we can take common out of here. So it should be 2 6 into 3 4 into 5 cube. So how many factors? So we have 7 into 5 into 4 equal to 140. Let's take a look what we have done over here. Let's see if that thing that has been right or not. Okay, so again, it's a beautiful question, simple question. It's exactly a CAT. This sort of question has been asked in CAT, not exactly, but something slightly like this only. So if you have done it, great, cheers for you. That it means that you're coping up slowly and slowly. Now let's do another question over here. Okay, we can take how many integers are divisible by or you can say are multiple of, rather you can say multiple of both 25 to the power 970 and 25 to the power 975. Let's think of it. It won't take that long. So what we can do is you can just follow the same concept. So 25 to the power 970 just to the prime factor, we can write into 970, or we can write 5 into 970 to 0, 7 to 14 and 19. Similarly, we can write 25 975 into 5 square 975. So how would it go? It would go 5 to 7 to 5. Okay, now what do we need? How many integers are multiple by both of there? So you can see we can start with 5 here and we can go to here. So it will be 5 19 41 5 19 42 5 19 43. It will go till 5 1949. So multiply by both. So these numbers will be multiple by both. These integers, okay, are a multiple of both these and this. This is very simple. Again, think for it. Look at this solution for a moment. Again, very simple concept, nothing. So what we would have in total, we would have 11 such factors. So these numbers would be all factors. Okay, very simple question. Again, this is one of the CAT questions, similar. We can do another question over here. Okay, anything that you're not understanding, you can simply put it in the comment box. Okay, so that I can reach out to you, or you can email it to me as well. My email that is provided in the link over here, it's available all 24/7. So you can go ahead and you can email it to me any time of the day. That's not a problem at all. So what we can do again, let's say if n equal to 1980, find the number and sum of its even factors. Again 1980. Okay, we have already done this sort of question before as well, so we'll try to do it. So 1980, again 2 into 9, 190, or we can do 33 into, this should be 99 into 10, so 10 33, we can take 3 into 11 into 3 into 2 into 5, so it should be 2 square into 3 square into 11 into 5. So what do we have now? Okay, so find the number and the sum of its even factor. Okay, fine enough. So what do we have? First of all, this is the total number of factors. So from here we can derive 3 into 3 into 2 into 2. So we have 3, 3, 9, 4, 36. Now this is the total number of factor. Now how do we derive the even factor? It's very simple. We know 2k. So what we can do, we can take 2 common out of common over here. So once we take 2 common here, so it will be, I believe, if we take 2 common over here, so we will have 2 into 3 square into 11 into 5. So you will have 2 to 4, 2 into 2, 4 into 2, 8 into 16. So we would be left with, we would be left with these many factors. So these are the number of even, find the number and the sum of its even factor. Okay, so we can go about again to finding the sum as well. So okay, it should be 24, I believe. 3, 2, 2, 2, so it should be 24. So 24 is the number of okay, so so 24 is the number of so if we 1980, so 24 even factors. How? We know even factors are in the 2k form. So that's one of the things. Now we need to know the sum of the factors. So we have already seen before how would be the sum of those even factors. So let me go ahead and do this over here. Okay, in order for me to derive sum, there is something I'll have to teach over here, because I don't think I've taught you deriving sum. I've only done with the product of two number. Product of two number is done, of factors is done, sum is left. So I'll come over to that as well. Okay, so if we see over here 1980, so again let's do the 2 into 3, because it was 99, so 3 into 3 into 11 into 2 into 5, that's what it should be. So 2 square into 3 square into 11 into 5. So what do we need to see over here? We need to go back to the basics, very basics, to get the sum. It says 2 square, so what all would be the factor? 2 0, 2 1 and 2. 3 square, so 3 0, 3 1 and 3 2. Then it says 11, so you have 11 square and 11, and then it says 5, so 5 square and 5 1. So add it up over here. So you have 4 plus 2 6 plus 1 7, you have 9 plus 3 12 plus 1 13, and then you have 11 plus 1 12, plus you have 5 plus 1 6. So what do we get when we multiply this? So we get 37 91, 91 6 is 6, and 9 6 54, and then again we multiply 6, we get 6 6 36, and 6 4 24, 7, and 6 5 33, 6 6 36, 6 4, okay, 6 5 32 32. So this would be the entire sum. This would be the entire sum for all the products. For all the products of 1980, this would be the sum. Again, look over here. For all the factors, we'll be doing with the 2, then 3 and 11, whatever the prime factors we have, and then we'll be multiplying it one by one. There's a formula for this as well. Now you can use it if you want. You can use the formula as well. 2 plus 1 minus 1 by 2 minus 1. 3 2 plus 1 minus 1 by 3 minus 1, and then 5 1 plus 1 minus 1 by 5 minus 1. So what will we get over here? We get 2 cube, 8 minus 1 7, we get 3, we get 3 27 minus 1, we get 26. Okay, and then we get 5 plus 25 24 multiply, sorry, 26 by 2 13, and we get 5 2 24 by 4, so we get 6. So what we're getting is exactly the same. See, you can see over here. Let me do this over here. Okay, 1980. Just we need to remember this. And so what we're trying to learn, we are trying to learn sum of all the factors of a number. That's what we're trying to do. So 1980, we got 2 into 3 into 3 into 11 into 2 into 5, got 2 square into 3 square into 11 into 5. This is, we know how to know that, and how to define the product of all the factors. Now we're trying to do the sum of all the factors. So we have learned this previously as well. See, there are two ways, as I said before. The first is formula. Simply what you can do, 2 plus 1 minus 1 by 2 minus 1. I'll tell you why. I'll come on to the explanation of formula as well. 3 2 plus 1 minus 1 by 3 minus 1, and then we have 11 1 plus 1 minus 1 by 11 minus 1, and 5 1 plus 1 minus 1 by 5 minus 1. So this is one way to do it. Okay, now other ways, simply see over here. 2 square means how many factors we have in 2? 2 0 2 1 and 2 square. In 3 square we have 3 0 3 1 and 3 2. In 11 square we have 11 0 and 11 1, and in 5 square we have 5 0 and 5 1. If you want to further break it, it's 1 2 and 4. So these are the factors of 4. Similarly, 1 3 9 are factors of 9. We have studied this in previous videos, so I hope you would have seen them. If you have not seen them, please go back, see them, and then go and get back over here. You will understand it more elaborated manner. And then you multiply over here. So you add it up, all the factors, because we need to add it up. So add it up over here. So we are getting 4 plus 2 is 7. We're getting 9 plus 3 12 plus 1 13. We're getting 11 plus 1 12, and we're getting 5 plus 1 6. So this is what we're getting. So we're getting something like this, and exactly once we do this, so 2 into cube, 2 cube minus 1 is 7 by 1, so this is 7. Then we have 3 square, 3 cube minus 1 is 26, and 3 minus 1 is 2, so 26 upon 2 is 13. Again 11 2 is 11 into 11 square is 121, minus 1 is 120 into 10 is 12. So let's write over here. And then here 5 square is 25, minus 1 24, and 5 minus 1 is 4, so 5 minus 1 is 4, so we get 6. Exactly the same thing. So this is all the factors of, or this all the sum of a factors. Okay, sum of factors. Okay, I'll do a couple more questions so that you can understand it, and then we'll generalize it. Okay, so let's do sum of all the factors of 240, 720, 100, 36, 52. Okay, we'll do this one by one. So 240, 24 into 10, 24 is 8 into 3. So you have, we can write it over here, 2 cube into 3 into 2 into 5, which gives us 2 to the power 4 into 3 into 5. So again, we need to find sum. So there are two ways to find sum over here. One way, we know 2 4 with 2 0, 2 1, 2 2, 2 3 and 2 4. 3 is 3 0 and 3 1, and 5 is 5 0 and 5 1. So now we add it up. So 16, 8 24, 4 28, to 20, 30, 31 should be. Over here you have 3 plus 1 4, and you have over here 6. So what do we get? 6 for 24. So we have 24 and 72 7. Okay, same thing we can do using formula as well. So 2 3 plus 1 minus 1 by 2. Oh sorry, over here that's a 4. 2 4 plus 1. Okay, and then 3 1 plus 1 minus 1 by 2. 5 1 plus 1 minus 1 by 2. So 25, we know 30 30, we are getting 2 2 2 to 4 8 16. So we are getting around 30 over here. It's 2 minus 1 exactly. So this is where I'm mistaking, little mistakes. So it should be 2 minus 1 over here, it should be 3 minus 1, and it should be 5 minus 1 over here. So it should be 31 over here, and then it should be 4 over here, and it should be 6 over here. So if you multiply both ends, it will be 744. So similarly you can do for 720 again. For 720, 72 into 10, 72 is 36 into 2 into 2 into 5, which gives us 2 cube into 3 square into 5. So again, two ways to do it. First way, 2 cube, we know 2 cube is 2 0, 2 1, 2 square and 2 cube. So this is 8 plus 4 12, 2 14 plus 1 15. Then we have 3 0, 3 1, 3 2, you have 9 plus 3 12 plus 1 13, and 5 is 5 0, 5 1. So you have 5 plus 1 6. So you have 15 into 13 into 6. Now let's check it. It's our formula. So 2 you have, so you have 3 plus 1 by, sorry, minus 1, and you have 2 minus 1. 3 2 plus 1 minus 1 by 3 minus 1. 5 1 plus 1 minus 1 by 5 minus 1. So 8 minus 1 into, okay, no, sorry, 16. 4 is 16, minus 1 is 15. 3 3 9 minus 1 8 by 2 is 8 by 2 is 4. Again 3 3 9 27, 21 26, 26 by 2 is 13, and 5 is 5 25 minus 1 24 by 4 is 6. So exactly the same thing. So this is what we call as the product, sum of all the factors. Okay, so now can we generalize something over here? Try to generalize it over here, see if we can generalize something or not. So can we generalize generalization of what? Sum of products. So let's see, PQR again. PQR in caps, remember, is a number with factor, or you can say prime base, p to the a, q to the b, r to the c, and we need to make sure we need to have the sum of all the factors, sum of the product, not sum of all the factors. We need to find all the sum of the factors. Okay, so can we do something like this? P a plus 1 minus 1 by p minus 1 multiplying q b plus 1 minus 1 by q minus 1 and r c plus 1 minus 1 by r minus 1. Can we do something like this? Isn't it? That's what we have been doing. Just for an example, we need to find the sum of all the factors of 72, which is 36 into 2. So we have 3 square, isn't it? So what we can do is, this is by formula method. Of course we have other methods as well. So we can't do 3 plus 1, which is 4, minus 1 by 2 minus 1 into 3, 2 plus 1, which is 3, minus 1 by 3 minus 1. So it should be 2 into 8 minus 1 is 7, and 3, 26 by 2 is 13, is equal to 91. All the product should be 91. 7 into 13, this is come from 13 into 7. Okay, so this is how we can generalize the sum of the products. Okay, now let's go back to the question, what we were trying to do. So we're trying to find, we had a number, we can take any random number again, and we were trying to find, let's say, find all the find the sum of all the even factors of 72. Okay, this was something related what we were doing. So again, 72 can be written as 2 cube into 3 square. So what we're trying to do over here, we are trying to find the sum of all the numbers which is in the form of which is in the even find sum of all the even factors of 7, only the even factors. So that's not at all difficult. So there are two ways to do this. Again, first we can do is, we can take the sum of all the factors. We need even factors. So what we can do, we can take sum of all the factors, and we can subtract sum of all the odd factors, isn't it? Think for it. If we can take sum of all, so again, so we know how to take the sum of all factors. So we can use a formula, or we can use other way as well. It's not at all harmful. So if we use a formula, this is what we're going to do: 2 3 plus 1 minus 1 by 2 minus 1, 3 2 plus 1 minus 1 by 3 minus 1, or we are going to 2 4 16. So we are getting 15 into, we are getting 3 27 26 13. So 15 45. This is what we are getting. Now we need to take sum of all the odd factors. So odd factors, we have 3 square. So how much it would be? So 3 square, if we are going to by the formula, 3 plus 1 minus 1 by 3 minus 1. So again we are getting 13 over here. So if we take 13 out of all the factor, 5 3 2 19 1 8, this is what it should be. We can do it in the second method as well. Again, sum of all the factors we can take from here. 2 3, it means 2 0, 2 1, 2 square, 2 cube, 3 0, 3 1, 3 square. That's all. So this is, of course, it would be 8 plus 4 12 plus 1 13 plus 1 14. It should be, I guess, 8 plus 4 12 2 14 plus 1 15. This should be 15, and this should be 9 plus 3 12 plus 1 13. so 195, and again taking 13 out of it, so it should be 182. So this is the sum of even factors. So I'm just trying to see if there's something that is, so just to check, let me do one more question. So this should be primarily, I believe this should be the last question that I will be doing, and then we'll be doing some more concepts in the next video. So let's see. Okay. How many even factors of 1080 are divisible by, we can take 12, but not by 30? Okay, just try to see what you can derive. So it's 1080. Okay, so again 1080 is 108 into 10. 108 is 12 into 9, and 12 is 2 into 2 into 3. So into 3 into 3 into 3 into 2 into 5, or we have 2 cube into 3 cube into 5, 8, 5, 47. Okay, now it says it is divisible by 12 but not by 30. So it is divisible by 12, so 12 gives us 2 into 2 into 3, which gives us 2 square into 3. This is what we need to find, but it also says that it should not be divisible by 30. 30 is 6 into 5, so 2 into 3 into 5. So we need to find all those numbers, all those even numbers, even factors of 1080 that are divisible by 12, but these are not divisible by 30. So again, so divisible, as I say, how many factors are divisible by 12 but so it shouldn't be that difficult. It should be 3 into 2 equal to 6. There should be 6 even factors of 1080 which would be divisible by 12, but it will not be divisible by 180. Let me do this over here. So if we take 1080, how many factors do we have? Let's try to find out. So if you see it over here, it should be 1, 2, 3, 4, 5, 6, 8, 9, 10, 12. What else it will be? 12, and then it will be 18, 15 also, 15, 18, 20, 24, 27, 30, 36, 45, 40 as well, 40, 45, 54, 60, 72, 90. And after 90, what all do we have? And we have 33, 60, 360 can be done as well. 108 up to 90, I believe. 108, 120, 135, 180, then 265, 216, 216, 270, 360, then 540 into 2, and then 1080. So these many numbers divide actually. So let's see. First of all, if you want to check the factors, so it should be 4 into 4, 16 into 32. It should be 30. This should be 32 factors. So we can count it down: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there should be now the square root. If you remembered in the first class, so square root 31 is the square root is between 30 square root is 900. So 31 would be 31, 32, 64, and 96, 602. So 33, 99, 33, 99, 108. So it should be between 32 and 33. this way. So we can check with this that it will be exactly 32. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. Exactly 16 before its square root and 16. That's what we said, that if there is an n, so the fact is before square root and after square root are equal. So that's what I was trying to figure over here. If it is before 16, it will be certainly 16 after that. So now what we need to see, we need to see all those which are divisible by 12 but not divisible by 30. Okay, so with 12 we have 12, 24, 36, 60 it cannot be because 60 is divisible by 30 as well. So we have 108, and then we have 108. 120 we cannot take because 120 is divisible by both 30 as well. So we cannot take any number which is divisible by 30. Okay, so it is 72, it has to be 72. So 12, 24, 36, 72, 108, and then it has to be 260, because this is all rest of these numbers. Let me write it over here. That it has to be 12, 24, 36, 72, 108 and 210. So these are the 6 numbers that are divisible by 12. So it was not a difficult question, looked difficult, but exactly it was. So let's call it up for the day, and in next class I will be dealing with other different features in number system, and then we'll be also getting to know about the divisibility rules and everything else. So let's wait for that. Till the time, thank you so much for your time. I hope you would have learned something new. Please go through the video again and again. If you find any error, any mistake, please don't feel shy to